So every time I hear stereotactic, whether it be SRS or SBRT, I know that it means high dose rates in one or few fractions to small targets. And I think, please, oh, please get it right for the patient's sake. It is our duty here at Standard Imaging to provide our customers with excellence in precision and accuracy so that they can confidently treat patients safely. The QA StereoChecker offers outstanding precision and accuracy with unbeatable 200 micron resolution. With fast and consistent setup and high-speed image acquisition, physicists can ensure that their CyberKnife machine is at peak performance every day. While originally designed specifically for CyberKnife QA, to provide fast and filmless means to perform that QA, it is also used on other Linux systems to provide quick analysis of single field images. Since performing QA with film can be an arduous and expensive task, not every possible QA test is done on a daily basis. But honestly, confidence in stereotactic treatments gained through rigorous QA is very important. And if there's a way to perform more QA tests more frequently in less time, then physicists deserve that opportunity, which is provided by the QA StereoChecker. Take the MLC picket fence test, for example. It is a recommended daily test. However, it is only a subjective test without any recommended test criteria to measure against. Whereas the garden fence test, recommended for monthly QA, does have test criteria and error thresholds recommended by Accuray. Each of these tests take the same amount of time to run on the machine, so why settle for qualitative when you can get quantitative data by running the garden fence test daily with the QA StereoChecker? Knowing the MLCs pass those 4 test criteria is surely a great way to start the day's treatments with the highest level of confidence. The upcoming QA StereoChecker release offers a reimagined, locally hosted web application, making navigation throughout the software easier and faster. While a user acquiring data will lock out other users from performing QA, additional users may access the software at the same time to review QA or examine QA trending data. Images are acquired with a single click, and within mere seconds, the full image analysis is done with the results displayed, saved, and trended automatically. With a richly enhanced user interface, QA StereoChecker 2.0 will continue to provide amazing 200 micron resolution, detecting errors well below Accuray's recommended thresholds for all tests. The ability to examine radial profile results against a baseline at every 5 degrees provides the details behind the results to facilitate troubleshooting any issues in the iris batch test. The upcoming version will include an iris panda test in addition to the currently existing fixed cone panda test. As a reminder, the panda stands for position and delivery analysis. This test replaces the Accuray film-based AQA test. Not only does it replace the AQA test, it provides more complete information as the results include the left-right, superior-inferior, and anterior-posterior shifts in addition to the total magnitude shift. The MLC garden fence test has been completely reconfigured as well to provide absolute leaf position data. The MLC leaf positions are analyzed against Accuray's 4 recommended test criteria. 2 test criteria examine leaf positions by bank, percent of leaves passing per bank, and the mean offset for each bank. The other 2 criteria are specific to individual leaves, the number of segments where a leaf position is offset by greater than 0.5 millimeters, and whether any one leaf position is offset by greater than 0.95 millimeter. Hovering over a leaf tab will display the expected position, the actual position, and the deviation from expected. Review tickets are brand new to the software. These tickets provide the daily QA summary results for review and sign-off by an authorized physicist. Individual or multiple tickets may be marked as reviewed with an opportunity for the reviewer to add additional comments that become part of the report and permanent record. If any alerts or errors are noted on the ticket, the timestamp is a link back to the daily results. Single field analysis for LINAC and CyberKnife QA is reimagined as monthly QA. Like all daily tests, single field images are acquired, analyzed, and results displayed, saved, and trended with the single click of the Start button. Metrics for flatness, symmetry, field width, and penumbra are calculated and trended. Full inline and cross-line profiles are provided. Also brand new to StereoChecker 2.0 is the addition of a SQL database, which enables the trending of all metrics analyzed within the software. A dashboard summary provides a quick overview with full data displayed in chart and table views. Last but certainly not least are reports. We now provide nicely detailed reports for both individual QA sessions and longitudinal data. So what else do we offer to make CyberKnife QA faster and easier? One tool is our CyberCross device that simplifies Phantom and QA device setup. As with many of our products, it is thanks to physicists sharing their clinical and QA challenges that led us to develop a solution for one particular challenge. And what is that challenge? Well, as CyberKnife users or potential customers know, this system is not equipped with a crosshair marker of any type, as the system uses fiducial skull or spine tracking for positioning. However, the system is equipped with an internal laser, which the CyberCross converts to a crosshair. CyberCross is simple to install and use to accurately position all types of QA equipment in the direct primary beam of the CyberKnife system. The CyberCross device can be installed on fixed, irised, and incise MLC collimator housings. CyberCross attaches to the CyberKnife system's proximal coupler and is held in place by set screws. CyberKnife commissioning and annual QA require the acquisition of scans at a 15-degree offset. Once again, a laser point is insufficient for easy alignment of a 3D water scanning system. This task is made fast and easy with the CyberCross installed and locked in the offset position. The CyberCross uses a lens to create a laser crosshair. As such, the device requires a simple calibration procedure before first use. Note that this calibration will be machine-specific. Adjusting the lens affects the shape, line thickness, and location, centering of the crosshair. These diagrams highlight the calibration steps, with the black reticle representing the calibration template and the red reticle representing the laser crosshair beam. Here, our QA StereoChecker alignment markings are being used to adjust the device crosshair shape and location. Once calibration is completed, it can be used anytime a crosshair is needed. It is easily attached for alignment, then detached for QA procedures, such as delivering QA plans for analysis with, or preferably without, film. No presentation about CyberKnife QA is complete without talking about our full package solution. That package includes our Stereotactic dose verification Phantom, SDVP for short. This compact Phantom is versatile and easy to use for QA commonly done with detectors and film. Perform a rigorous check on your TPS's reconstruction capabilities using the target and avoidance structures in the Dosimetry QA insert. We also provide heterogeneity inserts excuse me, in lung equivalent materials for performing Monte Carlo type calculations, something normally found only in much pricier phantoms. The top hat and cradle are newer additions to the SDVP. The cradle lifts the phantom to securely position it for posterior lesion QA. The top hat includes tighter fiducial marker placement to facilitate fiducial tracking of smaller targets. Excellence in small field dosimetry is something we also offer to complete our QA solution. One detector commonly used in the SDVP is our X-Radon 826 micropoint chamber, the ideal reference class micropoint chamber with a spherical spot size of 4.3 millimeters. The 826 is constructed of all low Z materials, providing users with a predictable response curve for small field measurements. To measure the smallest of small fields, we offer the first generation scintillator W1 with a 1 by 3 millimeter fiber. And as a dual channel detector, it is used in combination with our best-in-class Supermax electrometer. Or better yet, the latest scintillator, the W2, has a 1 by 1 millimeter fiber and is used in combination with the Max SD for water scanning. Both scintillators have a KQ of 1, making them ideal for stereotactic QA.